Hello, welcome to your lesson on the presentation of data. All right, imagine you have this situation. A zoo is open 360 days in the year. The number of visitors each day was recorded and displayed in several different types of graph. So, number of visitors per day. Okay, let's see how we can represent that. Here's one way to present it. This is called a frequency histogram. We can see here 100 visitors, so that'll be in the middle here. So this is 0 to 200 visitors. So there are 0 to 200 visitors on 20 days of the year, or 200 to 400 visitors on 20 some days of the year, and so on, and all those stacks. So this shows us that on about 90 days, there were between 1,000 and 1,200 visitors. And here's another way to represent that same data. This is called a pie graph, or a circle graph, sorry, a pie chart or circle graph. Here we can see the same information shown in a different way. Here's 0 to 200 visitors, and it's this number here. We can see, again, a small number of the whole, right? Where's the most visitors? 1,000 to 1,200 visitors happen 90 times. So where's that? 1,000 to 1,200, and you can see here it is a big number of the whole here. So this graph also is a nice way of showing which parts are larger than the others. Here's another representation. This is called a box plot or box and whisker plot. We'll talk more about that in this video. And another common representation of data is called a cumulative frequency graph. Looks like this. We will focus in this video on histograms and box plots, and in an upcoming lesson we'll look at cumulative frequency graphs. All right, so these are all different representations of data. All right, so frequency histograms. A frequency histogram is very similar to a bar chart. However, in a histogram, there are no spaces between the bars. Let's take a look at that in just a moment. Bar charts are useful for graphing qualitative data, such as color, preference, or whereas histograms are used for quantitative data. So remember, we began the unit with this. Qualitative data is data talking about characteristics. Quantitative is about numbers. So again, bar charts better for qualitative, histograms better for quantitative. In frequency histograms, as in bar charts, the vertical axis represents frequency. So let's take a look at an example here. Here's a histogram. So the vertical axis represents frequency, which is a count, right? And the horizontal axis represents the number of things, right? So again, this is our daily visitors to the zoo. We can see this is a histogram because, as it said, a histogram, there are no spaces between the bars. You can see the bars just line up beside each other. And the reason for that is because this is a continuous variable here, right? Remember, we have discrete and continuous variables. This is continuous. The number of visitors can take on any value, and we want to say it can be, therefore the bars are connected, right? But let's take a look at the difference between bar charts and histograms. So again, it mentioned above here that a bar chart can have spaces and is better for qualitative data, and that's what we can see here. We're seeing the number of people that speak different languages, I guess, and we don't need these to be connected because this does not represent a number scale on the axis. So we can just see this is 40 people speaking Spanish and 60 Chinese and so on. That's a bar chart. But this is still a count or a frequency. And here's a histogram, and this is GDP, and it says GDP in percentage by year here. So GDP amounts between the years here that have gone by. All right, so we can see this is now a histogram. The bars are connected. It is continuous data, but it's still showing frequency here. All right. Let's go on from there. Just a hint, a bar chart is suitable for discrete data, kind of mentioned that already, and there will be gaps, and a histogram is suitable for continuous data with no gaps. Okay, so now, if you're making a histogram, we can always begin with a frequency table. We've already made these before, but let's go back to these now to take a look. Let's say we have this data here. It says Belinda collected data on the time in seconds that girls and boys in her year group took to complete a 100-meter run. So here's all the girls' times for the 100-meter run. Here's all the boys' times. Okay, they're already sorted from least to greatest for you, so that's going to make it easier to work with. So let's say we want to complete this table first, okay, frequency table. So here's the way they broke this down into these times between 11 and 12 seconds, and then 12 to 13 seconds, and on all the way to 23 seconds. Notice again we have Here, not equal to 11, but equal to 12. So anything between 11, 12, not including 11, but including 12, and on and on. And for the girls, this has already been done for you. There was no girls with a time between 11 and 12, none between 12 and 13. 2 girls, as you can see, ran between 13 and 14 seconds, and on and on. And this frequency table right away shows you a lot of girls ran between 16 and 17 seconds, and so on. All right, now fill in that for boys. What would the numbers be here? All right, let's check your numbers. There we have it here. Okay, hope you were able to come up with that from the data set. And now here's a frequency histogram for the boys data. Because once you have a table, it's easy to create a histogram. Because a histogram, you basically take this axis and you can categorize it the same way you categorize the table here. So the same breakdowns, 11 to 12, 12 to 13, and so on and so on. And then you just make the bars show the frequency here. So for that first bar, the frequency is 2 boys, and the next time gap here was frequency of 4 boys. So you can see here 2 and then 4. So this shows you just the count. And this represents the same thing we see here, where the most boys are running between 14 and 15 seconds. We can see that here, 10 boys, and then kind of off in both directions like that. So that's a histogram. And notice again, it's continuous data. The times are a continuous variable. The bars are connected. Frequency is on the axis here. That's a histogram. Now we can go from there and create what are called box plots. But in order to create a box plot, we need to know the max, the min, and the quartiles. And we talked about quartiles in the last lesson. So let's see what we have here. For the girls, we have, it says fastest time, slowest time, or the minimum time and the maximum time. And that's from our data table. And then we also have the quartiles here. All right, so those can be gathered from the data. Can you do the same thing for the boys? Can you get the lowest, the highest, and then the median, and then Q1 and Q3? So remind yourself how to find those. So here's the data. I'll go back to the data here. Go ahead and find lowest, highest, and then the 3 quartiles. All right, let's check. For the boys, you should have acquired these numbers here. Here's the lowest time, highest time, median, the middle value, and then the 2 quartile values. If you didn't get those right, maybe a recap how to do quartiles. All right, now that we have those, we can create a box plot. To create a box plot, we need those 5 numbers. These numbers are called the 5-number summary for a data set. The min value, the max value, and the 3 quartiles, Q1, Q2, Q3. So we have those for boys and girls. And you can see, for example, for boys here, when we draw a box plot, here, this thing's called the whisker. That's your minimum value. And for boys, remember, it was 11.5. And the maximum value here, 20.5, 20.5. And here in the box itself is Q1, median, Q2, and Q3. Okay, so min, max, Q1, Q2, Q3. So those are the 5 numbers. And the box plots allow us to really compare data sets visually. Because now when you look at the boys box plot versus the girls one, you can see in general the girls take longer times for the run. And the median value for the boys is lower. You can see that there's, both of them have most of their data in the bottom half and bigger spread of data in the upper half. And that makes sense because most of the boys were running at low end and the girls as well. And then there was few that were kind of outliers in terms of the longer 100-meter run. All right, so we'll do more with box plots now. Let's keep going. Okay, so box and whisker plots. To draw a box and whisker plot, you need 5 pieces of information called the 5-number summary. We just talked about those. They are the smallest value, the min, the lower quartile, the median, the upper quartile, and the largest value. Here you can see they put LQ and UQ, but usually we say Q1 and Q3. All right, an outlier is a value that is much smaller or much larger than the other values. We'll take a look at outliers in a moment, but an outlier is a point less than, let's see, like if you take 1.5 times the IQR and subtract it from Q1, or if you do 1.5 times IQR and you add it to Q3, that is where you find the outliers. All that will be explained very soon. But for now, again, this is a box plot, min, max, Q1, Q3, median here. All right, so let's talk about outliers a little bit. Here's a data set. Clearly we see an outlier value here. So in a set of numbers, a number that is much larger or much smaller than the rest of the numbers is called an outlier. So here again is a scatter plot of data. We can see here potential outlier, and maybe even these two are outliers. They're just kind of separated significantly from the rest of the data. Now, how do we find outliers in a univariate data set? The process is this. We kind of mentioned it already, but basically you do 1.5 times the IQR, or interquartile range, and you look for that amount above or below Q1 and Q3. Let's look at that visually. So let's say we have this here, we have Q1 here, Q3. This could be an outlier here in a box plot. So what you would do here, for this example here, to find the IQR, it's Q3 minus Q1, right? So Q3 here is 90 or a little bit less, and let's say it's about 90. Q1 is about 70, so I subtract those, I get IQR of 20. So now I do IQR times 1.5, like it tells me here. 20 times 1.5 is 30. So that tells me if I go 30 below Q1 and 30 above Q3, anything beyond those is an outlier in the data. So Q1 minus 30, so if I go from here 70 minus 30, I get to 40. So that means anything below 40 is an outlier, and this one definitely below 40. All right, on the upper end, you do it as well. Q3 plus 30, so Q3 was 90 about, plus 30 brings me to 120, so I have this long gap here. Anything beyond that is an outlier, but we don't see any more data out there. So this is our only outlier here. Let's take a look at that for this data set here. In this data set, we have shoe sizes for a group of students, and we have them broken down by gender, female shoe sizes, and male. And these are frequency numbers here. So for example, 2 females have a shoe size 34, no males. Here at 37 shoe size, there's 10 females, 3 males. And for example, the most males have a shoe size of 39, 12 of them, and so on. So these are frequency numbers. So your job is to draw a box and whisker plot for females and males and compare the two plots and state whether they're symmetrical, comment on outliers. Well, let's get started. First of all, I'll get you started on the females. So for females, our 5-number summary is this: 34, 37, 38, 39, and 40. Where did those numbers come from? Well, again, this is the minimum, and we see a minimum shoe size for females is 34. This one is the maximum. We can see there's no females that are at these high shoe sizes. There's some here though, so 40. And then this was our median, and Q1, Q3. So again, if you don't remember how to find median, you can say how many females are in this data set. You can count up all these frequency numbers here. You get a total. You do n plus 1 divided by 2, and it'll tell you the position of the median, and then you find it like that. So make sure you know how to find those numbers, the median and then the Q1, Q3. And once you have that, you can find the IQR by doing Q3 minus Q1 right here to get an IQR of 2. Once you have the IQR, you multiply by 1.5 to help you find the outliers, right? So 1.5 times 2 is 3. So you go 3 below Q1 and 3 above Q3 to figure out where your borders are for outliers. In that case, our borders are 34 and 42, and there are no data values that fall below or above that for females, so there are no outliers. Now repeat for males. Do the same thing. Oh wait, before that, notice we've created the box plot after that. We have our minimum value here, maximum, our Q1, Q2, Q3. There's a nice box plot. All right, so repeat for males. What is the 5-number summary, and are there any outliers? Calculate that. Let's check your work on that now. So the 5-number summary is given here. IQR is 2 as well. And then if you go below Q1, 35 is our border. And if you go above Q3, 43 is our border. That means, do we have data below or above that? Yes, we have one data point for males above 43, which is 49. That's our outlier. Okay, to wrap things up, one more thing I want to mention about box plots. We already know box plots are a visual representation of the 5-number summary, the minimum value, the maximum, and Q1, Q2, Q3. So here's what we know so far, right? Here's min, here's max, here's Q1, Q2, the median, and Q3. That's a box plot. We know from Q1 to Q3 is the interquartile range. We know from min to max is the full range of values, and that's what a box plot looks like. Now, and maybe you already knew this, or maybe you already put it together based on the idea of quartiles, but you should know that when you look at a box plot, this part here from the whisker to Q1 represents 25% of the data set. And then from Q1 to the median is the next 25% of the data set, and then the next 25, and at the end from Q3 to the max, the last 25% of the data. That's important to know. Again, that's why these are called quartiles. They break the data into 4 equal parts. Okay, so let's look at that visually and with some real data. Here's a group of 32 students, and they took some kind of test with a maximum mark of 10. Here are the results we see. If you lay that data out in order, it looks like this. And I've already kind of broken the data into 4 parts. Those are like the quartiles, right? So now the median is right here. Q1 is right here. Q3 is right here. Okay, the data has been broken into 4 equal parts. Each one, if this is 32, then each of these parts must be 8, 8, 8, and 8 pieces of data. All right, so that's 25%. That's the next 25. And if you're making a box plot, it will look something like this then. Here's the box plot, right? The minimum value is 0. The maximum value, the maximum score in the data set was 10. Our median was at between 5 and 6, which is 5.5 right here, median. Our Q1 value was between 3 and 4, which is 3.5 right here, 3.5. And our Q3 value is, well, between 7 and 7, which is 7 right here. So there's our box plot. And again, you can see the box plot does not look symmetrical, but this still represents quarters, right? This is our median value here, our Q1, our Q3, and we know that we have percentages of data. So between 0 and 3.5, we know that's 25% of our data set. And that's like this, 0 and 3.5. That's 25% of our data lies between these values here, right? And on and on. This would be 50% of our data, because between Q1 and Q3, it's 2 quartiles. So this is 50% of our data. So half of our results for this data set lie between 3.5 and 7. And that makes sense. Half of the data is between 3.5 and 7 right here. There's half of the data, 50%. And finally, this would be the upper 25%. So it's important to understand that relationships between the data and the box plot and what it represents. All right, so look at this example we have here. We have box and whisker plots shown for weights in kilograms of 24 male poodles and 24 female poodles. And right away, looking at the 2 box plots, you can see in general, male poodles are heavier, right? Because the whole box plot is a little bit more to the right here. But some female poodles are heavier than some male as well. So now look at these questions here. Write down the median for both groups. Okay, and now write down the IQR for both groups. Finally, number 3 here, write down the percentage of female poodles that weigh less than 24 kilograms. What percentage weigh less than 24? And last question, write down the percentage of male poodles that weigh between 26 and 30.5 kilograms. Okay, I hope those questions were not too bad. Again, here's our median values, and that is just found by this middle marker here. Our male IQR, you just do this value, Q3 minus Q1, and for female, Q3 minus Q1, that's the IQRs. And for writing down the percentage of female poodles that weigh less than 24, well, you look at this, you're like, here's 24, which is actually the median value. So female poodles that weigh less than that, well, below the median, which is the halfway mark, that must be 50% of our data. And finally, male poodles between 26 and 30.5 is right here. Well, that's from Q2 to Q3, so that's 25% of the data here. All right, great. Now you've seen box plots, you've seen outliers, and you know how to use these visually. Great job. We'll see you soon.